Hello everyone, we're HLF. This is episode 3 of the series How to Make a Drone. Today we will discuss about some mathematical rules and their implementations because they are necessary in drone making. It will help us to figure out the exact configuration of the components that will allow us to make a quadcopter drone which is balanced both mechanically and electrically. Now the question is how to choose the right components. The answer are 4. Calculate lifting capacity of the drone, find motors with proper kV rating, find ESCs with proper ampere rating, calculate the battery power you need. Now let's see how to figure this out. Lifting capacity calculation. Give the drone double thrust than its weight. Well, thrust is the force that works upward and gravity is the force that works downward. And rule number 1 becomes average thrust equals to 2 into gravity. For example, if the drone's weight is 1.5 kilogram, then it has to have the thrust of 3 kilogram to fly. Now, how can I calculate drone weight if I have not already made one? The answer is simple, using online specifications for each component. A demo of weight calculation of the drone parts is shown here. For motor's weight is 200 grams, the frame's weight is 405 grams, for ESC's weight 140 grams, weight of the battery is 188 grams. Then the weight of all electronics and parts such as nuts, bolts and wires are 100 grams. It can be even more. The total becomes 1033 grams. And double of that weight becomes 2066 grams. Want to see how to find out online specifications for each component? Let's have a look. Well, we're in the Hobby King website now, and here we will find the weight of each part from its specification. For example, this one is the S500 quad frame, and if you go down in the specification, you will find its weight, which is 405 grams. The next one is 1000 kV brushless motor. Go down in the specification, you will get the weight, which is 52 grams. But there is another weight here, which shows 83 grams. Then from where did this extra 30 gram came? Well, this is the weight of those bullet connectors and wires. We will avoid it for now because we have already added 100 grams extra at the time of calculating drone weight. This is 30 ampere ESC. Get down in the specification, you get the weight, which is 32 grams. And the last one is the 2200 milliampere hour lithium polymer battery. The weight of this thing is 188 grams. Let's go back. Now the ideal rule is 70 to 80% of the maximum pull or throttle capacity should be equal to double of the drone weight. For example, maximum pull or thrust of a D2826 2200 kilovolt motor is 960 gram. So the maximum thrust of the drone will be 3840 grams, and double of the drone weight is fixed, which is 2066 grams. So in this case, the drone will fly at almost half of the throttle capacity, which is 53.80%. There is also another example here that shows when the motor kV decreases, the thrust decreases, and in that case, the throttle capacity has to be increased to fly the drone. Throttle is a channel or a stick of the remote to control the thrust. We will talk about that in later episodes. Finding motors with proper kV rating. Now which one will I use? A low kV or a high kV motor? The answer is low kV motor. Why? Because low kV motor requires ESC and battery of less ampere rating, so less power consumption occurs, and so a smaller size of battery with low ampere can be used, and so less weight of the drone and more thrust. How to choose proper ESC? Here comes rule number 2. ESC current rating should be in between 1.2 to 1.5 times more than the maximum motor current. For example, maximum current of a D2826 2200 kV motor is 34 ampere. In this case, the ESC current has to be in between 40 to 51 ampere. There is also another example here that shows when the motor kV decreased, the maximum current required also decreased, and thus the ESC current rating required also decreased. So, a 1000 kV motor requires 15 to 20 ampere less ESC ampere rating than a 2000 kV motor, which will allow us to save both weight and money. How to choose proper battery? Here comes rule number 3. Current supply rate of the battery is equal to battery current into battery discharge rate. For example, maximum current of a D2830 1000 kV motor is 21 ampere. So maximum current consumption capacity of 4 motors becomes 84 ampere and its 80% is 67.2 ampere. Again, the current supply of a 2200 mAh 30C LiPo is 66 ampere hour maximum with 4 equal distribution of 16.5 ampere hour for each ESC maximum. So we can use a 20 ampere ESC because maximum current capacity of ESC, which is 20 ampere, is greater than the current supplied to that ESC, which is 16.5 ampere. On the other hand, maximum current consumption capacity of the motor is 84 ampere hour, which is greater than maximum supply current of battery, which is 66 ampere hour. So this configuration will give us optimum performance, maintaining safety of motors and ESCs, and this is all what we want. There is also another example here. You may look at this if you want. I'm just going through. Low kV motor requires a smaller size battery and ESCs, so less weight, more thrust and low cost. Just maintain the optimum thrust while lowering the motor kV. There are some online LiPo battery calculators for multicopters. For example, this one is shown in the description. Calculate maximum flight time. Here comes rule number 4. Maximum flight time equal to battery current divided by current supply rate multiplied by 60. For example, if a drone draws constant current of 20 ampere from a 2200 mAh LiPo, the flight time will be 6.6 minutes. From rule number 3, we get the current supply rate of the battery is equal to battery current into battery discharge rate. So the higher the battery current, the higher the flight time. But the lower the battery discharge rate, the higher the flight time. Wish you have learned how to find the component with proper configuration, don't you? So now make your component list and get ready to do some shopping. Because in the next episode, we will learn how to connect those components and make the drone. Until then, be prepared, stay connected, and don't forget to subscribe to our YouTube channel. See you soon.